Welcome to this podcast episode brought to you by AGS Agriculture Global Solutions, your partner for better farming practices in Malaysia.
Great to be here.
You know, I was just looking at the fertilizer prices this morning.
Mm.
It's enough to make you sweat, isn't it?
It's the one thing on every planter's mind.
Absolutely. And it feels like everyone I talk to, from the big estates in Pahang down to the 10-acre guys in Johor, is in the same boat. You have to feed the trees, but the cost of that feed is just, it's eating up all the profit.
It is, and the natural reaction is either to cut back, which hurts your yield, or to just double down on the cheapest NPK you can find.
Right. And that actually brings me to a conversation I had last week. I was walking a small holding. Trees are maybe 20, 25 years old. And the owner, he just kicks the ground, and it's hard as a rock. He says to me, I keep throwing NPK at it, but the soil just feels dead. And it really got me thinking about the invisible cost of how we've been farming.
That dead soil feeling, it's a real thing. It's soil fatigue. For years, we've treated the soil like it's just a sponge, pour in nitrogen, pour in phosphorus, and the tree drinks it up.
And that's it.
But we're forgetting the soil is a living thing. When you only use inorganic fertilizers for 2 decades, you change the whole chemistry. The pH drops, the soil gets acidic, and it just compacts into that concrete you were talking about.
Which is exactly why I'm so excited about the study we're looking at today. It offers a way out of that cycle. And the best part is, it's not from some lab in Europe. It's from Simalungun in Sumatra.
Which makes it incredibly relevant for us here in Malaysia.
Exactly.
The soil types, the rainfall, it's basically a mirror of our own planting areas. And crucially, this wasn't done on young palms. They used 24-year-old trees.
The 1996 generation, I mean, that's a huge portion of the palms standing in Malaysia right now.
It's the critical age. These are tall, heavy trees. Their root systems are getting old. How you manage them in these final years before replanting is everything.
Okay, so let's get into it. The solution they looked at was empty fruit bunch compost, OPFB. But we're not just going to say compost is good. There's a specific sweet spot dose.
There is, and this is the part that really grabbed me. You can actually have too much of a good thing.
Really?
Oh, yeah. The data we're going to unpack shows there's a precise amount, 12 metric tons per hectare, that doubles your primary root growth. But if you get greedy and put on 24 or 36 tons, you might actually do more harm than good.
It's that classic case of more is not better, better is better. Okay, but before we get to the solution, let's just nail down the problem. What is actually happening in that dead soil?
Well, the study points to a few things. Inorganic fertilizers give you that quick hit of growth. They're like an energy drink.
Right, you see the flush of green.
But they do nothing for the soil's cation exchange capacity. It's CEC.
Okay, let's pause there. Cation exchange capacity. In simple terms, for a farmer in Perak, why does CEC matter?
Think of it like the soil's battery. A high CEC means the soil can hold on to nutrients, potassium, magnesium, and save them for the roots. A low CEC.
It just washes away.
It just washes away. With our heavy rains, you're literally washing money down the drain. You pay for fertilizer, the tree everything gets to eat.
And that's not all, is it? It makes the soil more acidic, too.
It does. And as the soil gets more acidic, the beneficial life, all the little bugs and bacteria, they start to die off. The soil compacts, and you end up with that concrete floor.
Which brings us to the alternative. Empty fruit bunches. I mean, for years, EFB was just a problem for the mills, right? A mountain of waste.
A huge problem. We used to burn it, which is now illegal, or just dump it raw. But composting turns that waste into a resource. And if you're a smallholder near a mill, it's often a cheap, accessible material. The question is just, how do you use it right?
So this study at the Bukit Maraja estate, they had a very specific setup.
They did, yeah. It was a proper scientific trial. They took these 24-year-old palms and tested different amounts. They had a control group with 0 compost.
The baseline.
And then they stepped it up. 12 tons, 24, 36, and then a massive 48 tons per hectare.
And they weren't just looking at the bunches, they went underground.
And that's where the real insight is. We all tend to stare at the canopy because that's what we see, that's what we harvest. But the engine of the tree is the root system. If the roots are failing, everything you see above ground is it's just a matter of time.
Okay, let's talk about that underground engine. The researchers looked at primary, secondary, and tertiary roots. Let's start with the primary roots because those numbers were just shocking.
They really were. First, we need to be clear what a primary root is. These are the big anchors. They grow straight down from the base of the palm.
Deep.
Very deep. They can go down 2 meters. They're what holds the tree up in a storm and what finds water in a drought. They're the survival roots.
Right. So the data, What did it show?
Okay, so the control group, the trees with no compost, had about 75 primary root strands on average.
75. Okay.
Then they looked at the 12 metric tons per hectare treatment. The number of primary roots just it shot up to nearly 158.
Wait, from 75 to 158, that's more than double.
It's a massive, massive upgrade to the tree's foundation. But here's the twist. The part that doesn't seem to make sense at first.
What happened when they added more?
When they went up to 24 tons per hectare, the root count didn't go up again. It crashed. It dropped all the way down to about 50.
50? That's even lower than the control group that got nothing.
Significantly lower. And it stayed that low for the 36 and 48-ton treatments as well.
How is that possible? I mean, usually if you add more food, you get more growth. Why would more compost kill the primary roots?
It's about physics and oxygen. Roots have to breathe. When you pile on 24 or 48 tons of heavy, wet organic matter, you create this thick, dense mat on the soil surface.
It smothers it.
It smothers it. It becomes anaerobic. There's no oxygen. So the primary roots, which need to grow from the base, are basically suffocated before they can even start.
Okay, that makes sense.
There's another idea, too. The tree might just get lazy. There's so much water and nutrients right there at the surface in that thick mat.
So it doesn't bother sending roots down deep.
Why would it? It stopped investing the energy.
Yeah.
So that 12-ton dose is the Goldilocks amount. Just right. Enough to help, but not so much that you smother the system.
Now, I did see that the secondary and tertiary roots, the smaller ones, behaved a bit differently.
They did, and that's an important detail. The tertiary roots, those are the really fine feeder roots right at the surface, they actually did a little better at the higher doses, like 24 tons.
Well, that makes sense. That's where all the food is.
It does, but you have to ask yourself, for a 24-year-old palm, what's more important? A few more surface feeders or a deep, strong anchor system that can find water?
Especially with the weather we've been having. You know, long, dry spells, then sudden, intense rain.
Exactly. A tree with only shallow roots is a fragile tree. It's the first to suffer in a drought and the first to fall over in a storm. The 12-ton dose gives you the best of both worlds. A great anchor system and a good boost for the feeder roots. It's the clear winner for resilience.
Okay, so we built the engine, we've got the roots sorted. Let's talk about the crew that fuels that engine. The study looked at the invisible workforce.
This takes us right back to your friend with the dead soil. You can buy all the expensive rock phosphate you want, but in our acidic Malaysian soils, a lot of that phosphorus gets locked up. It binds to iron and aluminium, and the tree can't use it.
It's like having a pantry full of canned food, but you've lost the can opener.
That is the perfect analogy, and these pea-solvent microorganisms, they are the can openers. They're bacteria and fungi that release the phosphorus.
And I'm guessing the compost had an effect on
A
it.
huge effect. And guess which treatment came out on top again?
It has to be the 12-ton dose.
The 12-ton dose. By far the highest population of these microbes. We're talking about an army of them. It was significantly higher than both the control and the really heavy 48-ton application.
Do you know who these little soldiers are?
We do. The main bacterium was a species called Ensifer, but the fungi were the really exciting ones. They found Aspergillus flavus and, this is the big one, Trichoderma asperellum.
Trichoderma. I see that name on bottles in the supply shop. That stuff is expensive.
Very expensive. And farmers pay for it because it helps root growth and fights off bad guys like Ganoderma. But here's what this study is telling you. You might not need to buy the bottle. By applying 12 tons of EFD compost, you are creating the perfect home to breed your own Trichoderma army right there in your soil.
So I'm not just applying compost, I'm ranching microbes.
You are ranching the microbes that will make your fertilizer budget go further. They unlock the phosphorus you already paid for 6 months ago. It's about efficiency.
That's a powerful argument. Okay, so let's zoom out from the microscope to something you can actually see. The visible workforce. The creepy crawlies.
Yes, the macrofauna. They counted every bug they found. And the star player, the most common creature by far, was the earthworm, Lumbricina.
78 earthworms. Anyone who's tried to dig in hard plantation clay knows finding a worm is a good day.
It's a very good day because worms are like a living pH meter. They're so sensitive to acidity. The soil here was 4.96. That's very acidic, right on the edge of what a worm can handle.
So the fact that they're there means the compost is making a difference.
It's buffering the acidity. It's creating these little safe zones where life can thrive. But why should you care about worms? Think of them as nature's plow.
That compacted clay we talked about earlier.
Exactly. Worms dig tunnels. In our heavy clays that get waterlogged during the monsoon, those tunnels are drainage channels. They let oxygen get down to the roots, and they physically break up the soil, making it easier for new roots to grow.
So it's a feedback loop. The compost brings the worms plow the soil, and that plowed soil helps the roots grow deeper.
And it wasn't just worms. They found earwigs, woodlice, ants. The biodiversity was just higher in the composted areas, period. A sterile soil is a fragile soil.
I really like that. It's not just dirt, it's a factory floor. And you've got to keep your workers happy.
And you don't do that by drowning them in 48 tons of sludge. You give them the right amount of food and the right environment.
Okay, let's pull this all together. I'm a farmer listening to this. I've got a field of mature palms. What's the prescription? What do I do tomorrow?
The prescription is the golden dose, 12 metric tons per hectare per year.
And let's be practical. What does that look like? A standard lorry is what, 6, maybe 10 tons?
That's right. So you're looking at 1, maybe 2 trips per hectare. But the key here is discipline. If you can get 30 tons for a good price, don't put it all on 1 hectare.
Spread it out.
Spread it out. You are much better off treating 2 hectares at a dose of, say, 15 tons than 1 hectare at 30. You cover more ground and you get better results.
And how do I apply it? Just spread it on the surface.
Just on the surface. Around the frond stacks is perfect. Do not till it in. You'll damage the surface roots. Let the rain and the worms do the hard work for you.
What if I'm on sandy soil, not clay? Does this still apply?
It does, and it might be even more important. On sandy soil, that organic matter acts like a sponge. It holds onto water that would otherwise just drain straight through. It's a universal soil improver.
And just to repeat the point on EFB, talk to your local mill. This is a resource for them.
It is. You know, the ash from burnt EFB has potassium, sure, but burning it destroys the carbon. Composting keeps that carbon and builds up your soil. You're not just feeding the tree for this month, you're building an asset in the ground for years to come.
It's a total shift in thinking, isn't it? We're so focused on feeding the tree.
And this is about feeding the soil.
Yeah.
That's the whole point. If you feed the trichoderma, if you feed the earthworms with this 12-ton dose, they will feed the tree for you. They'll find the water, they'll unlock the phosphorus. You're basically outsourcing the hard work to nature.
And nature works for free, as long as you give it what it needs.
It makes every ringgit you spend on chemical fertilizer work harder. You're not just throwing it into a dead sponge anymore.
That's a powerful place to end. It's efficient, it's backed by science, and the material is right there at the local mill.
It really is.
Before we go, just one final thought for everyone listening. We talked about 12 tons being the sweet spot.
Yeah.
Imagine if every smallholder in Malaysia aimed for that. We wouldn't just be improving our own yields, we'd be restoring soil health across the entire country. It starts with one decision on your own land.
And remember, farming is a long game. The roots you build today with that compost, they're what will get your palms through the drought next year.
Absolutely. Well, that's all the time we have for this discussion on unlocking soil wealth.
My pleasure.
Remember to visit our AI farming assistant at cropdrive.ai to learn more on how to increase your oil palm yields and incomes. Thanks for listening.